Hello everyone. So today we're going to talk about mode shapes. We're going to continue off from where we started before with the 2 degrees of freedom system. And in order to do that, what I'm going to do is take the last frequency matrix that we did together in the previous parts 1 and 2, and then we're going to build off of that. And then so basically right now what we have here is our frequency matrix that we've built together, and then what we're going to do here is basically off of that we're going to do the amplitude ratios. So the amplitude ratios is basically it's really simple. So we're going to start with amplitude ratios. So x1 here, that's your So R1 is your amplitude ratio for system number 1. That's your system number 1. That's your system number 2. So remember we had this equation here. This was our x1 term. This was our x2 term. So what we're going to do is basically this equation existed like this before. Omega m plus k1 plus k2, and that's going to be negative k2 x2 equals 0. So we're going to arrange this equation here, right? Not this here, but this here, this equation here, and rearrange to solve for x2 over x1. If you do that, you'll end up with this equation right here, and that's what this is going to be. That's x2 over x1. And then we're going to denote that this is for system number 1 by using this here, this subscript, basically, upper script, sorry, and in parentheses, in brackets, denoting the number 1. That's going to be basically, that's amplifying that this is system 1. So now we off of that, what we're going to do is build the equation. So if you rearrange for x2, that's going to be negative m1 omega 1 squared plus k1 plus k2 over k2. So that's going to be your first amplitude ratio. Now if you rearrange this equation here and solve for that's your system number 2. We're going to rearrange this equation and solve for x2 over x1. You will end up with k2 over negative m2 omega 1 squared plus 2k. So, and then we're going to do for system number 2, R2. That's going to be the same thing. However, we're going to use, that's denoting system number 2. And they're basically equal to each other. However, the only thing that's going to change here is your omega. That's going to change. Everything else is going to be the same thing. Okay? Sorry, I did a quick mistake here. K1 plus K2. Oh, pardon me. Sorry. No, that was right. Wow. No, that was right. That was right. Sorry about that. Ignore what I just did right now. Okay, so then that's going to be equal to K2 over negative M2 omega 2. See that change there? Everything else is the same, but this is going to be different. So that's going to give you your R1, R2. And then your mode shapes are basically, this is what your mode shape will be. you will end up with mode shape 1, which is basically for system 1, that's going to be x1, x2, and that's going to be x1. When you calculate it, right, you're going to get your user omega, your calculated omegas that you found before, and then that's going to be r1, x1, system 1, and your and these are just vectors here, where that's your x1 of system 2, your r2, x1, and that's about it, folks. So you've got your two mode shapes. So these are basically known as vector modes, x1, x of system 1, x of system 2. These basically, they denote the normal modes of vibration, and they're also known as modal vectors of the system. In later videos, I'll show you how to solve for basically how to solve these modal shapes and get, solve for initial conditions and whatnot. But that's it for now. Thank you very much, and we'll see you later.